Hello students, in Standard 6th, Chapter 1, Natural Resources, Air, Water and Land, we have studied about the properties, composition and uses of natural resources. In Standard 7th, Chapter 3, Properties of Natural Resources, we are going to study in detail about the different characteristics of natural resources like air, water and land. First, properties of air. Air is all around us. We cannot see it, yet we feel the presence of air. When we inhale, air is taken in through the nose. If we blow on our hand through our lips, we can feel the air. To learn the first property of air, there is one activity which you can do at home. The activity is as follows. Take a stick from a broom or a paper or a plastic straw. Tie a thread at its center and hang it so that it remains horizontal. Tie two rubber balloons of the same size at the two ends of the stick. See to it that the stick remains horizontal. Now, remove one balloon, inflate it, means feel air in it, and tie it again at its original position. Does the stick remains horizontal? You will see that the stick goes down on the side of the inflated balloon. This shows that air has weight. Air is made up of many gases like oxygen, hydrogen, nitrogen, carbon dioxide, etc. Like all matter, it has mass and weight. Now, what is matter? Matter is everything around us. It is something that occupies space. What is mass? Mass is the amount of matter present in a substance, and weight is the gravitational force that acts on this mass. Atmospheric pressure. To study atmospheric pressure, there is one simple activity. You can do this activity at home if you have an injection syringe. Take an injection syringe without the needle, pull its piston and observe it as you do so. The piston can be pulled out easily. The piston then remains in that position even if you let it go. Refer to the first picture on the screen. Now, close the inlet hole of the syringe tightly with your thumb, pull the piston and let it go. Please refer to the second picture on the screen. Is the force required to pull out the piston more or less than before? Does the piston remain as it is even after you let it go? The molecules of gas are always moving. Molecules are made up of one or two atoms. When these molecules hit an object, they create pressure on that object. Here, the object is the syringe. When the syringe is held in hand, the air molecules hit the syringe and create pressure on it. This pressure of air created on any object is called atmospheric pressure. When the inlet hole is closed and you try to pull the piston, you will find it very difficult to pull the piston. You have to apply more force to pull the piston. And when you let go of the piston, it is immediately pushed in. Why does this happen? When you pull the piston with the inlet hole closed, more space becomes available to the air in the piston and it becomes rarefied, means becoming less dense, and it starts moving freely in the syringe, and hence the pressure on the inside of the syringe becomes low, but the pressure of the outside air is very high. So when the pulled out piston is released, the air outside, that is the atmospheric pressure, immediately pushes the piston inside. If this experiment is repeated, holding the syringe in different positions like vertical, horizontal or inclined, the piston is found to go in to the same extent in all the cases. From this, we can infer that atmospheric pressure is the same in all directions. Daniel Bernoulli was a Swedish scientist who put forth the important principle that the pressure of air decreases when its velocity increases, while the pressure of air increases when its velocity decreases. If a body is moving through air, the air pressure decreases perpendicular to the direction of the motion, and then the air in its surroundings flows rapidly from higher pressure to the lower pressure. Let us study about Bernoulli's principle by doing an activity. Bernoulli's principle. To understand Bernoulli's principle in a better way, let's do an activity. Take some water in a plastic cup and hold a straw upright in it. Hold a small piece of another straw near the upper end of the first straw and perpendicular to that straw. Blow hard through the small piece of straw. You will see a fountain of water. Why did this happen? When you blow through the straw, the air at the open end of the erect straw is pushed away. When you push the air away, it moves with greater velocity. As it moves with greater velocity, the pressure decreases at the opening end of the erect straw. This is stated in the Bernoulli's principle. As the pressure of the air near the opening becomes less than the atmospheric pressure, the water in the cup is pushed upwards from where the pressure is higher to where the pressure is lower. The water comes out in the form of a fountain. When there is difference in air pressure, the air always flows from the place of higher pressure to the place of lower pressure. Humidity of air. Humidity is a concentration or amount of water vapor present in air. Let's study humidity of air by doing an activity. Take ice cubes in a glass and keep the glass on a table for some time. You will see that droplets of water appears on the outside of the glass. How did this happen? The ice cubes in the glass cools down the air surrounding the glass. As the water vapors in the air cools down, it condenses and gets transformed into water, and these droplets collect on the outer surface of the glass. The level of humidity is different in different places. Similarly, the humidity levels also changes from time to time during the period of a single day. The level of humidity of air depends upon the capacity of air to hold water. At night, the temperature of air is low and its capacity to hold water is less. So, the extra water vapor is transformed into water droplets. This is called dew. In afternoon, the humidity drops as the temperature rises. There is less moisture in the air and we feel that air is dry. The proportion of water vapor in the air is high during the monsoons and in coastal areas. As a result, we feel the dampness or humidity. Scattering of light. Air is a mixture of fine particles of gases, dust, smoke, and moisture. These particles are opaque. So, when light rays fall on them, the particles spread the light in all the directions. This phenomenon is called scattering of light. Temperature regulation. The earth receives energy from the sun. The energy is in the form of heat. When the sun's heat reaches the earth, it has to travel first through the atmosphere. The constituents of air, like gases, water vapor, absorb some of the heat and pass it on to one another. As a result, the earth's surface becomes warm and suitable for the living world. If there were no air on the earth, the average temperature of the earth's surface would have been very low. Transmission of sound. For transmission of sound, medium is necessary. Air is a medium. The particles of air carries the sound in the form of waves. Density also plays an important role in transmission of sound. Density is the amount of space occupied by an object having mass. In winter, the density of air increases, means the amount of medium increases, and so sound travels faster in winter. Example, we can hear the whistle of a distant train clearly early in the morning in winter. Properties of water. Water is a colorless, odorless, tasteless substance found on earth. It is made up of hydrogen and oxygen. It is very important for the survival of living things. Water occurs in liquid state under ordinary conditions. Water is a fluid substance. It does not have any shape but has volume as it occupies space. It can pass through small holes or cracks. Freezing is one of the important properties of water. Let's study freezing by doing an activity. Take a plastic bottle, pour some water in it, mark the water level on the bottle. Keep this bottle upright in the freezer for making ice. Open the freezer after a couple of hours and observe. You will see that water has changed into ice. Note the level of ice. You will find that the ice level is higher than the water level before freezing. What can you infer from this? As water freezes, it forms ice, it expands, and its volume increases. Density. Density is a measurement that compares the amount of matter an object has to its volume. Density is nothing but the space occupied by an object which has a specific mass or weight. If an object is heavy and compact, then it has high density. If you see on screen, you will see that the solid is more densely packed, means the particles present in solid are more tightly packed as compared to liquid and gas. This tells us that solid particles or a solid object is more dense or has more density than liquid and gas. Density of water. To understand density in a better way, let's do an activity. Take some water in a glass and add a few pieces of ice to it. What do you see? You will see that ice floats on water. Ice is lighter than water. When water freezes to become ice, it becomes lighter than the original liquid. When water freezes, that is, when it transforms into a solid state, its volume increases. The density of ice decreases as the particles start moving away from each other. Therefore, the density of ice is less than that of water, and that is why ice floats on water. Anomalous behavior of water. Usually, when the temperature of a substance is lowered, its density increases as the volume decreases. But water is an exception to this rule. Let us study this behavior of water by doing an activity. Take a glass of water. Let's take the temperature of water as 20 degrees Celsius. Keep the glass of water in a freezer. The water starts cooling, means the temperature goes on becoming lower and lower. The density starts increasing, that is, the water particles start coming closer to one another. But when the temperature of water reaches 4 degrees Celsius, the water starts behaving abnormally. At 4 degrees Celsius, the density of water is maximum. As the temperature falls below 4 degrees Celsius, its density starts decreasing, means the particles of water starts moving away from one another. It expands and its volume increases. The water gets converted into ice. This is called anomalous behavior of water. Anomalous behavior of water also helps in survival of aquatic organisms. This layer of ice, that is the top layer of ice, acts as an insulation and prevents heat from escaping the water and the cold outside from coming inside the water. Thus, it helps in survival of aquatic animals and fishes. Take 2 big glasses of water. Add 4 to 5 spoonfuls of salt into the water in one glass and dissolve it completely. Now place a potato in the water in the second glass. You will see that the potato sinks in glass A where only water is present. Take out the potato from that glass and put it in the salt water and observe. You will see that the potato in glass B starts floating because the density in glass B is more because of salt. The particles of salt and water mix with each other and becomes dense. The density of potato is less than that of salt and water combined together, and hence it floats. When salt is added in water, its particles spread in water and becomes smaller and smaller. Ultimately, they become so small that they cannot be seen. That is, they completely mix with water. This is what is called as dissolving. Solute. Solute is a substance that dissolves. Example, salt. Solvent is a substance in which the solute dissolves. Example, water. Solution. Solution is a substance that we get when solute dissolves in solvent. Uses of water. Water is useful for transport due to its fluidity. Water falling down from a height is used to generate electricity with the help of a generator. Water is a good coolant and it is used in motor vehicles to control the temperature of the engine. Many substances are readily soluble in water. Water is also called as universal solvent. Water is used as a solvent in factories, laboratories, foodstuffs, and in various types of biological processes occurring in the body, such as digestion, excretion, etc. Water is useful for cleaning purposes, such as bathing, washing clothes, etc. Properties of soil. Soil is made up of mixture of organic matter, gases, liquids, and organisms that together support life. Color is a vital property of soil. Soil gets its color from the minerals and the organic matter. The minerals present in soil are iron, potassium, magnesium, calcium, and sulfur. Humus is the organic matter present in the soil. It is made up of decomposition of dead plants and animals. You have already studied about humus in Standard 6th, Chapter 1. Soil can be of different colors: red, black, yellow, copper, grey, etc. Color of the soil is used for indicating several properties of soil like fertility, drainage of water, capacity to hold water, etc. Soil texture. Texture tells us about the size, quality, feel, appearance of an object. Soil texture is determined by the proportion of particles of various sizes in it. To understand soil texture, an experiment can be performed. You require 3 measuring cylinders, 3 glass funnels, filter paper, water, fine sand, silt soil, soil from an earthen pot used for growing plants, that is clay. Procedure. Fit cones of the filter paper in the 3 glass funnels. Fill the cones with equal quantities of sand, silt soil and clay respectively. Place the funnels on the measuring cylinder. Pour 1 test tube of water into each of the funnels and observe how much water is collected in each measuring cylinder. Please refer to the first picture on the screen and observe the diagram A. You will see that the amount of water collected in the first cylinder is more. First cylinder contains sand. It is made up of large particles and water can easily drain through it. It is easy to plow the soil. This soil is less fertile because it has silicon dioxide or quartz in large amount. It does not dissolve in water and therefore has very little capacity to supply nutrients to the crops. Let's consider second cylinder. Second cylinder contains silt soil. It is made up of medium-sized particles. It is not as plowable as sandy soil. It has large amount of organic matter. Its capacity to supply nutrients is much greater. This soil is also called as sedimentary soil. Sedimentary soil is made by weathering, that is, breaking down of rocks, and by action of wind and water. Third cylinder. Third cylinder contains clay soil. It is made up of very small particles. This soil is smooth. It has high water holding capacity. Soil structure. It is the arrangement of the solid parts of the soil. It depends upon the different shapes of particles in the soil. Different forms or shapes of soil. First is columnar. This structure have columns. Second, laminar. Groups or aggregates of soil particles are arranged in thin horizontal plates. Third, granular. This structure are individual particles of sand, silt and clay grouped together in small, nearly spherical grains. Fourth, block shaped. This soil structure stick together in nearly square or angular blocks. Uses of soil. First, plant conservation. Soil helps the plants to grow. Second, water conservation. Soil holds water by means of bunds, lakes, ponds, etc. In this way, we can use water throughout the year. Third, plasticity. Soil can be given any required shape. This property of soil is called plasticity. We can make variety of articles using this property of soil. These articles can be baked to make them hard. Example, pots, idols, bricks, earthen lamps are articles made from soil. Some useful types of soil. First, china clay or kaolin. It is white in color. It is used to make crockery, bathroom tiles, tanks, laboratory apparatus, masks, jar, etc. Second, shadu soil. It is whitish in color. It is used for making statues and idols. Third, terracotta soil. This soil is red in color. Decorative articles and pots used for growing plants are made from this soil. Multani soil. This soil is used in cosmetics. Soil testing. Soil testing is done to determine the amount of various ingredients present in the soil. Soil is tested for color, texture, amount of organic matter present in it. This is done to identify any deficiency of ingredients and to decide what measures should be taken to remove the deficiency. Soil samples are collected for testing. They are dried in open space in the shed for 8 to 10 days. It is then sifted through a sieve. Sieve is used to separate small particles from large particles. pH and electrical conductivity tests are useful in finding the characteristics of soil. pH test is based on the concentration of hydrogen ions. An electrical conductivity test is the measurement that correlates soil properties like soil texture, fertility, salinity, organic matter level, etc. that affects crop productivity. Causes of diminished soil fertility. First, if soil pH is less than 6 or more than 8. For the proper growth of plants, the soil pH should be between 6.5 to 7.5. Second, low proportion of organic matter. If the soil is devoid of organic matter, then it won't get proper nutrients. Third, no proper drainage of water. Water should easily seep through soil. It should not remain on top surface. The roots should be able to absorb the water. Fourth, Repeated cultivation of the same crop. Growing same crops repeatedly diminishes certain nutrients in the soil. Fifth, continuous use of saline water affects plant growth. Sixth, excessive use of chemical fertilizers and pesticides. Chemical fertilizers like urea, ammonium chloride reduces drainage of water and air circulation.